So, good morning to all. Today's class content is design of shafts, keys, and couplings. First, knowing about the shafts, first we want to see the transmission shaft. It is a rotating bumper, usually a circular cross section used to transmit power or motion. It supports transmission elements like gears, pulleys, and sprockets. A transmission shaft supporting a gear in a speed reducer, which is shown in figure that you can see clearly. The shaft is always stepped with a maximum diameter in the middle portion and minimum diameter at the two ends where bearings are mounted. Thus, the transmission shafts are made of medium carbon steels with a carbon content from 0.15 to 0.40%, such as 30C8 or 40C8. Thus, commercial shafts are made of low carbon steels produced by hot rolling and finished to size either by cold drawing or by turning and grinding. The steel bars up to 200 millimeter in diameter are commercially available. The standard sizes are given in the table. You can see clearly. There is 5, 20, 45, 90, 22, 50, 100, 25, 55, 28, 60, etc. The specific categories of the transmission shaft. First, we are seeing this axle, which supports the rotating elements like wheels, hoist and drums used in rear axle, rear axle of the railway wagon, automobile rear axle, etc. This is commonly we are using daily. You can see it daily. Then the spindle. In the machine shop, you can see in the lathe we have a spindle. The spindle is a lot. The spindle is a short rotating shaft used in all machine tools, such as the small drive shaft of a lathe or the spinding of a drilling machine are the examples of the shafts. Then you can see the counter shaft used in the gearbox. The counter shaft is a secondary shaft driven by the main shaft and from which the power is supplied to the machine components, rotates counter to the direction of the main shaft. It is used in multi-stage gearboxes. As I already told about that. The stresses induced in the shaft. The transmission shaft are subjected to three stresses. There is axial tensile force, bending moment, or torsional moment, or their combinations. The formulas to find the tensile stress, bending stresses, and torsional shear stress are given. When the shaft is subjected to a combination of loads, the principal stress and principal shear stress are obtained by the Morse circle diagram. By constructing the Morse circle diagram, you can find the principal stresses and principal shear stresses. Then classification of shaft. That is design of shaft. There is two classified into two: design based on strength and based on rigidity. And the design based on strength are further classified into two. That is both at the theories of failures and by ASME method. And based on rigidity, classified into two. One is torsional rigidity, another one is lateral rigidity. First, you see about the design of shaft. Already I told the shaft is a rotating bumper usefully for circular cross section. It may be solid or hollow, whatever it may be. It transmits power, both will transmit power and rotation motion also. Motion elements such as gears, pulleys, flywheels, and clutches are mounted on the shaft and are used to transmit power from the driving device through a machine. Fit keys, dowel pins, and splines are also used in the shaft to attach the other machine elements on the shaft. The shaft rotates on rolling contact bearings or bush bearing, either rolling bearings or bush bearing. Commonly, we are using rolling contact bearings. The couplings are used to the couplings are used to transmit power from drive shaft to the driven shaft, that is motor to where it is applicable, that is with gearbox or wheels, etc. The materials used for shaft. The materials used for shaft should have the following properties: it should have high strength, good machinability, which have low notch sensitivity factor, which have good heat treatment properties, and it should have high wear resistant properties. Next, we say about the keys. Key is a machine element which is used to connect the transmission shaft to rotating machine elements like pulleys, gears, sprocket, or flywheels. A slot is machined in the shaft or in the hub or both to accommodate the key is called which is called as keyway. Why the keyway is produced that is reduces the strength of the shaft as it results in stress concentrations. There are five types of key. One is sunk key, saddle key, tangent key, round key, and splines. You can see one by one. First, we see about the sunk keys. The sunk key is a key in which half of the thickness of the key fits into the keyway in the shaft and half in the keyway of the hub. Half of the key will be shown outside of the shaft, so it will be connected to the hub. The saddle key, the torque is transmitted by friction only and cannot therefore transmit high torque and is usually only for light application. The saddle keys are used for only light applications. There are two saddle keys are available. There is one is flat saddle key and another one is hollow saddle key, which is shown in the figure. Next, we see about the tangent keys. Tangent keys are used to transmit high torque. They may be used as a single key or pair at right angles. Single tangent key can transmit torque only in one direction, that is shown in the figure. Then we see about the round keys. The round keys have a circular cross section and fit into the holes drilled partly in the shaft, which is shown in the figure clearly. It shows a slot is drilled after this assembly so that the shaft can properly align. Mainly these round keys are used for low torque transmission devices. Then last one is splines. The number of keys made as an integral part of the shaft are called splines. That you can see clearly in the diagram. In the shaft, number of keys may be produced. The keyways are provided in the hub. These are used for high torque transmission. Example in automobile transmission, splines are permit the axial movements. Then you can go for couplings. The couplings are used to connect two rotating shafts to transmit torque from one to another. For example, coupling is used to connect the output shaft of an electric motor to the input shaft of the hydraulic pump. There are two types of coupling. One is rigid coupling and flexible coupling. What the difference between rigid coupling and flexible couplings are? Rigid couplings are used to connect two shafts which are perfectly aligned. Only aligned shaft can be connected in the rigid coupling. In flexible couplings, we can use lateral or angular misalignment. All shafts also connected in the flexible coupling. Rigid couplings, there are three classifications. One is sleeve or otherwise called as muff coupling. And second one is split or clamp or it is called as compression coupling. And third one is called as flange coupling. In flexible coupling, there are three couplings are available. Bushed pin type coupling, universal coupling and old hands coupling. First see about the muff coupling. The diagram shows two parts are there. One is key, another one is sleeve, another one is shaft. So three parts are there. The sleeve hollow cylinder is fitted on the end of input and output shaft. The help of the sunk key. The key is that we are connecting the sleeve and the shaft by using the key. The diagram itself we can see that the torque is transmitted from input shaft to the sleeve through keys and from the sleeve to the output shaft through the key again. It requires more axial space, has small radial dimensions. That is clearly shown. Majorly, the factor of safety should be in between 6 to 8. Normally, it will be 6 to 7 or 8 and is used for the ultimate strength. The proportions are outer diameter of a sleeve can be calculated by using the formula capital D is equal to, that is capital D means outer diameter of the sleeve, that is 2 into D, 2 into diameter of shaft, small d plus 30, that is a standard value. And the length of the sleeve can be calculated by 3.5D, that is 3.5 times of the diameter of the shaft. Next we see about the flange coupling. The flange coupling consists of two flanges keyed to the shaft. The diagram itself shows mainly the flange coupling consists of 5 parts. One is flange, another is hub, another is shaft, another is key. And so in that the flanges are connected together by meaning of the bolts. Bolts are connected. Bolts are used to connect all the parts. The power is transmitted from driving shaft to the flange. The projection is provided on one of the flanges and the corresponding process is provided in the other for the proper alignment. The proportions are given here, that is outer diameter of the hub should be 2 times of the shaft diameter, pitch circle diameter bolt should be 3 times of the shaft diameter, and outer diameter of the flange should be the 4 times of the outer diameter, flange diameter, shaft diameter, and thickness of the flange should be half of the shaft diameter, and the thickness of protective circumferential flange should be 0.25 times of the shaft diameter. So this is all about the shaft keys and couplings. So thank you so much. I think it will be useful for you. Thank you.